Welcome back, Sethbling here. You're watching a skilled player play Super Mario World, but this player is not human. It's a computer program I wrote called MarIO. This program started out knowing absolutely nothing about Super Mario World or Super Nintendo's. In fact, it didn't even know that pressing right on the controller would make the player go towards the end of the level. It learned all of these things through a process called neuroevolution. In this video, I want to teach you about how MarIO learned to beat this level, Donut Plains 1, what his brain looks like, and how it's all based on actual biological evolution. So let's start out by actually looking at MarIO's brain. Let's play it again, but this time we'll look at MarIO's brain as it's making the decisions of what buttons to press. It's going to look a bit complicated at first, but don't worry, I'll help break it down for you. This structure of colored lines and blinking boxes is called a neural network. It's a simple mathematical model for how a brain works, but it can produce some very complicated behavior. With enough computational power, a neural network could come close to simulating a real human brain, but modern technology isn't there yet. On the left side you have the inputs. This is what MarIO sees. It's a simplified view of the level. The white squares stand for blocks the player can stand on, and the black squares stand for moving objects like enemies or mushrooms. On the right side you have the outputs. These are the 8 buttons that MarIO is able to press by using its neural network. In between the inputs and the outputs, all those lines and boxes, those are the neural network. Each free-floating box is called a neuron, and the lines connecting those boxes are like the axons and dendrites in a human brain. At any given time, only some of these neurons and connections are actually being used, and this is what people talk about when they say you only use 10% of your brain. The neural network you're seeing is a pretty complicated one, and it got so complicated as a result of a 24-hour evolutionary learning session. So, to explain how neural networks work, let's rewind about 24 hours and look at how the whole process started. This is what MarIO looked like at the beginning of its training session, all the way back in generation number 0. The program is probably even dumber than you thought at this point. Often it just stands there and doesn't even press any buttons. If MarIO stands still for too long, it'll cut off a simulation and try the next neural network, so it's mostly just jumping from one simulation to the next. But occasionally, the neural network says to press the right button, and the player starts walking right. The behavior isn't complicated, but it's enough to make at least some progress in the level. Let's take a look at a sample neural network to understand just how that works. This is one of the randomly generated neural networks that appeared in the first generation of the simulation. There are some green lines and a red line, and one neuron in the middle. Here's how it works. A green line is a positive connection, and a red line is a negative connection. A green line reading from a black or white square will turn its output the same color. A red line reading from a black or white square will turn its output the opposite color. In this case, the green lines read from the platform that the player is standing on and make the neural network press the right button as long as the player is standing on it. However, when the red line reads a black square representing one of those caped Koopas, it presses the A button and makes the player jump. This puts the player in a position where the green lines are no longer reading a white square, so the right button turns off and MarIO just stands there. This is a really basic example that illustrates how a more complicated neural network might operate. The more lines and neurons you have, the more nuanced the decisions can be. So, how exactly do we get those more complicated neural networks? The answer is evolution. When MarIO gets further right on the screen, its fitness goes up. In this case, fitness is a function of how far right it gets and how quickly it gets there. Only the neural networks that produce the highest fitness are selected to be bred, creating the next generation. It took 34 generations of genetic breeding and fitness evaluation before MarIO was able to finish the level without dying and get a fitness score above 4,000. You can see there were several places it got stuck for a few generations, but it always evolved out of those ruts. Let's take a look at a few of those ruts. You can look at the top left corner of the screen to see what generation number each rut occurred on. This process of picking the fittest individuals from each generation, breeding them together, and adding random mutations very closely matches the actual process of biological evolution that took single-celled organisms and produced intelligent humans. That's the power of neuroevolution. And though we don't yet have enough computational resources to produce something on the level of a human brain this way, it's kind of neat to see what it can do on one of my favorite games. I didn't come up with this idea on my own. This algorithm is called NEAT, which stands for Neuroevolution of Augmenting Topologies, and it's based on a paper by Kenneth Stanley and Risto Mikulainen. It's a really great paper that describes how to use genetic algorithms to build up neural networks from bare bones, without presupposing the best structure for the neurons and their connections. It also includes some really cool ideas for separating genomes into species, which a lot of genetic algorithms don't really try and do. I wrote MarIO from scratch in Lua as a plugin for an emulator called BizHawk. As I close out the video, let's take a look at the fittest neural network in each generation. It's kind of cool how sometimes you can see them make modifications to each other and improve performance, but sometimes an entirely new species becomes prominent and dominates the others. If you'd like to do more reading about the concepts I talked about in this video, I provided some links in the video description. I had a lot of fun working on this project and I learned a ton. Hopefully you learned something too. That's about it. Thanks for watching.